Hello everybody, and today you're going to be learning section 2.4 algebraic reasoning. In your student journal, you're going to turn to page 53. So that's where I'm at right now. I'm on page 53. We are going to do number 2. Okay. So I'm going to go ahead and I'm going to rewrite it over here off to the side so I have a little bit more space to do my work. So it's 20 minus 2 times the parenthesis 3x minus 1 equals x minus 6. Again, this is number 2 on page 53. So our directions tell us to solve. When we solve, our goal is to isolate the variable to get it by itself. So the first thing we always want to do is we want to get rid of parentheses. Okay, so the first thing I'm going to do is I'm going to distribute the 2 to get minus 6x plus 2. If you were thinking you could do the 20 minus 2 first, that is not allowed because the 2 is connected to the parentheses. So you cannot just make that 18 and then distribute 18. It will not give you the same result. The next thing I'm going to do is I'm going to simplify the left-hand side by combining like terms. That'll give me negative 6x plus 22. That equals x minus 6. From there, my goal is to get variable terms on one side and numbers on the other. So I'm going to go ahead and I'm going to move the x terms to the right, and I'm going to do that by adding 6x on both sides. So this isn't really a step, this is just some work that you might just do in your head. I'll keep the steps in orange. So that gives me 22 equals 7x minus 6. From there, I'm going to go ahead, I'm going to add 6 to both sides. When I add 6 to both sides, I get 28 equals 7x. That allows me to have variables on one side and numbers on the other. Last step is going to be to divide 7 on both sides. I'm going to do that part in my head. That will cancel out the 7, leaving me with 28 divided by 7, which is 4. If you want to have the x on the left-hand side, you can simply just switch this around to say x equals 4, and it means exactly the same thing. So your answer is x equals 4. Okay, so that's how you do number 2. In section 2.4, it's all about solving equations, but not only solving them, but giving reasons for what you are doing in each step. So I'm going to take a moment and I'm going to go over these algebraic properties of equalities. These are properties that we use all the time. We just don't really give them a name. And I actually did them in some of the example that I just did. Okay, so the addition property, for instance. The addition property is the idea that I can add something to both sides of the equation, and my equation is still true. So it's the idea of adding to both sides. And if I go back to my example, I actually did that right here. I added 6 to both sides, right? So that's the addition property. The subtraction property, you probably guessed, is when you subtract on both sides. So it's this idea that whatever you do to one side, you must do to the other side. The next step, multiplication, is the idea that you can multiply to both sides. And then for division property, it's the idea that you can divide to both sides or on both sides. You can say multiply to, multiply on, doesn't really matter. Substitution property is the idea that something can take the place of something else. So when you substitute, it's the idea that if they are equal, then they can take the place of one another. Or each other, take the place of each other, right? So say you know A equals B, if you have an equation like A plus C equals B plus D, if you know that A equals B, then I can substitute the A with B, and it still means the same thing. That's what the substitution property states. On the next page, we have a few more properties to do. So I'm on page 52. That was page 51. The distributive property is the idea that you take anything on the outside and multiply it to what is inside, and it's still equivalent. You can do distributive property if there's a plus sign inside or if there's a minus sign inside. Okay? And that's one that we're pretty familiar with. I also used that in the first example that I went over. Reflexive property. Reflexive property is the idea that anything is equal to itself. Symmetric property is the idea that you can flip the equation around and it's still true. Okay, and I did that in the example that we started with as well. And then the transitive property, I'm going to explain that one down here because there's a little bit more involved. So they have this, if you look up here, they have an explanation of each one of these in the first column. I'm just going to use that and explain it a little bit more. So let's say A equals B, and you also know that B equals C. Well, we know that B and B are the same thing, and so those are equal to each other, right? But if these two values, A and C, are both equal to B, so if we know this, then we can say that A is equal to C. It's sort of like saying, like, if A equals 10 and C equals 10, well, they both equal 10, so they equal each other, right? So that's a way to explain it. If you're thinking about this in words, it's a little bit harder to write, but it's the idea that if two items are equal to things, it could be variables, you can see up here, it could be segments, right? It could be angles. So if two items are equal to the same thing, then those two items are equal to each other. So those two things are equal, right? So that's what the transitive property is saying. And this one's kind of hard to recognize. So just, if you're not seeing anything else that's working, think about, could it be the transitive property? Okay. And again, it's this idea that two things are equal to the same thing, so therefore they're equal to each other. All right. So let's go back to that example that we did. In this example that we did, this first statement here that's in green, that was given to me. I didn't have to come up with that. But in the second part here, okay, what do you think is happening there? How do you think they got to that first step in orange, right? We use the distributive property. I'm going to abbreviate property there. Then the next thing that we did is we just combined these like terms. So that's not really a property, but it's still something that we did. So when we do things like combine like terms, we're just going to call that simplify. It's not a property. It's just adding two things or subtracting two things. That would also work for if you just multiplied some things together. You really need to think about the word simplify. Okay, the next step. How did we get to the next step? Well, in the next step, we added 6x to both sides in order to get this next orange step. So adding to both sides, as I talked about on page 51, is the addition property. Okay. And then in the next step, they went ahead and you can see again in purple that what I did is I added 6 to both sides. So to get from this step down to 28 equals 7x, I again used the addition property. And then finally, or not finally, we're almost there, I guess. In the second to last step here, I divided both sides by 7. And if you divide both sides, that's called the division property. Again, abbreviating property. Now, I could have stopped there because they just said solve the equation. Technically, I've solved it. But I went ahead and I flipped the equation around. It says the same thing. It's just what was on the left is now on the right, and what was on the right is now on the left. And remember from page 52, when you flip the equation around, but everything else is the same, this is what we call the symmetric property. And basically what you just did there is you did a proof. Okay, a proof is a step-by-step process that as you take a step, you give a reason. Okay, that's what a proof is. So this really is an algebraic proof that we just did. Now, to sort of formalize this, what we're going to do is we're going to take this and we're going to put it into two columns. Where you have your given and each of your steps here gives you 7 steps. On one side, I'm going to erase this right here. On one side, we have our statements, while on the other side, we have our reasons, justifying why we were able to make the statement that we did. So it's this idea that you make a statement, give a reason, make a statement, give a reason, make the next statement, give a reason, and so on and so forth until you get to where they wanted you to get to, which was to solve the equation and find the value of x. Let's do one more example. So flip back to page 49. On page 49, you'll see a big long proof here, okay? And so we're going to go through this, okay? I'm going to turn this into a 2-column proof here. All the way down. Okay. So I'm going to cross out where it says algebraic step and justification, and I'm going to, on the left, say statements, while on the right, we have reasons. Okay, just a little heads up about reasons. Reasons can be things like, well, as you saw, it could be given. It could be properties, like we've talked about today. It could also be a postulate. Postulates that we have talked about are segment addition postulate, angle addition postulate, just to name a couple. It could be theorems. It could be definitions. And one other that it could be, no pun intended, but simply put, it could be simplify. And remember, simplify is often used for things like combining like terms. Okay. So in this first problem here, the first step here, step 1, that's given to us. That's the original problem. That's the problem that they're wanting us to solve. So since they're wanting us to solve, we know at the end of our problem, it should be something like x equals, so that I know the value of x, or whatever variable it might be. For the reason they wrote write given equation, you could have just said the word given, and that would be enough. Okay, so to get to step 2, what you want to think of is, how did I get to step 2? The way I got to step 2 is I used the distributive property. And that's what you want to do with a proof. Step 3. After they distributed, you have to look and see, what did they do next? So the next thing they did, you can see they took the 6 minus 5 and they turned it into a 1. Okay, that's just combining like terms. So we would just say simplify. Step 4, you can see what's different. They have it bolded for you. They subtracted 2x and they subtracted 2x on both sides. Subtracting on both sides is a property that's going to allow us to move things from one side to the other. We call that the subtraction property. I'm going to abbreviate that subtract property for the sake of time. In step 5, you'll see that this 2x minus 2x is no longer there, and it's just 1, and the 5x minus 2x becomes 3x. So again, all they've done is combined like terms, so they simplified. Now remember, sometimes we do the simplifying in our head. This person did not do the simplifying in their head, so they have to justify those steps. If we were solving this, you might have skipped step 4 and gone directly to step 5, and therefore you would have just wrote subtraction property, and that's it. Okay. In step 6, they went ahead and subtracted 4 on both sides. So that again is the subtraction property. It is possible in one proof to use a property multiple times. Step 7, not really a property, but all they've done right here and right here is simplified it to see what they need to do next. In step 8, they went ahead and they divided both sides by 3. That's the division property. Dividing on both sides. In step 9, they went ahead and they simplified the negative 3 over 3 to get negative 1 and the 3 over 3 to get x. Again, that's just simplifying. Remember, simplifying is just, simple things like adding things together, subtracting things, multiplying things, or dividing things to make the equation simpler. In step 10, you'll see that all they did was flip the equation around, so this would be called the symmetric property. Okay, now most likely you wouldn't see this much simplifying in a proof, but because of the way this person solved the problem, we have to justify those steps with the word simplify. Okay, so that is an algebraic proof. I actually gave you 2 examples. This is another great example, and I really want you to see that it's something you already know how to do. It's just now we're giving reasons for each of those things that you are doing. The other things with proofs is I want you to notice that I did not do, specifically in this one, I did not do more than one step at a time. And that's really important with a proof, is that you take it one step at a time. It's really important to remember in proofs. Okay, so I hope you enjoyed this lesson, and best of luck with your practice.